Ever wondered how data travels over the internet? It's a fascinating process that's made possible by something called network system architectures. These architectures are the backbone of communication within and between networks. They provide the rules and protocols which allow data to be sent and received, whether that's an email, a web page, or a video call. At the heart of these architectures are two primary models: the Open Systems Interconnection or OSI model, and the Transmission Control Protocol Internet Protocol, also known as the TCP IP suite. These models are not just theoretical constructs, but are instrumental in designing, troubleshooting, and improving network communication. They offer a way to understand and to conceptualize the complex process of network interactions. So, if you're ready to delve into the intricate world of network system architectures, stick around. Let's dive into the first of these models, the Open Systems Interconnection or OSI model. Peeling back the layers of the OSI model. The Open Systems Interconnection or OSI model might seem complex at first, but it's essentially just a way of understanding network interactions. Think of it as the 7-layer dip of the networking world. Each layer has a specific function and communicates with its neighbors. Let's dive in. First up, we have the physical layer, or layer 1. This is where the rubber meets the road, or rather, where data meets cable. It's all about the physical transmission of raw data over a communication medium. We're talking electrical signals, cables, connectors, and network interface cards. Next up, layer 2 is the data link layer. Now we're getting into the nitty-gritty of node-to-node data transfer. This layer is responsible for error detection and handling. It's also divided into two sublayers: logical link control and media access control. Onto layer 3, the network layer. This is the layer that plays traffic cop, managing device addressing, identifying the optimal path for data, and handling packet routing. It's like the GPS of the network, guiding our data packets to their destination. Layer 4, the transport layer, is the reliable postman of the network. It ensures complete data transfer from source to destination. It's also responsible for segmentation and desegmentation of data and flow control. Layer 5, the session layer, is all about communication. It's the layer that sets up, manages, and terminates the connections between local and remote applications. Layer 6, the presentation layer, is the universal translator of the network. It translates data formats between sender and receiver and can also provide data encryption and compression. Finally, we reach the top of the stack with layer 7, the application layer. This is the layer that's closest to the end user and interacts directly with software applications. It's responsible for identifying communication partners, resource availability, and synchronizing communication. Throughout these 7 layers, our data is transformed from raw bits to meaningful information, passed from one layer to the next, each adding its own value. Each layer only communicates with the layer directly above and below it, keeping things orderly and efficient. So that's the OSI model in a nutshell, but how does it compare to the TCP IP model? Next stop on our network journey, the TCP IP model. This model, also known as the Internet Protocol Suite, is a more streamlined and practical model extensively used in real-world networking. So let's dive into its 4 layers, starting from the bottom. The first layer is the link layer, also known as the network interface layer. This layer corresponds to the physical and data link layers of the OSI model. It involves protocols and hardware that operate at the lowest levels of a network, such as Ethernet for local area networks, and the Address Resolution Protocol, or ARP. This layer's primary role is to enable data to move across a network interface, including error detection and physical addressing. Upper level, we have the Internet layer, also known as the network layer. This is the heart of the TCP IP model, providing the networking capabilities across diverse networks. The principal protocol in this layer, the Internet Protocol or IP, is responsible for the packet routing across the network. This layer ensures each packet of data reaches its correct destination by using logical addressing, such as IP addresses. Next up is the transport layer, strikingly similar to its counterpart in the OSI model. This layer manages the end-to-end communication process, ensuring data is transferred reliably and without errors. Key protocols here are the Transmission Control Protocol, or TCP, and the User Datagram Protocol, or UDP. TCP provides a connection-oriented service, ensuring all data packets arrive in the correct order, while UDP provides a connectionless service, which is faster but does not guarantee the order of delivery. Finally, we reach the application layer, the layer closest to the user. This layer combines the functions of the OSI's application, presentation, and session layers. It includes protocols that provide specific services, like HTTP for web browsing, SMTP for email, and FTP for file transfer. The application layer is where users interact with the network, whether they're sending an email, browsing a website, or transferring a file. So, how does the TCP/IP model differ from the OSI model? Well, the TCP/IP model is generally simpler, with just 4 layers compared to the OSI's 7. It's also more practical, focusing on the protocols used in the real-world internet. However, both models serve a common purpose, to help us understand how different network protocols interact and work together to provide network services. Comparatively, while the OSI model is more theoretical and comprehensive, the TCP/IP model is more practical and is used as the backbone for the internet. It's not about which model is better, it's about understanding them both to gain a comprehensive understanding of how networks operate. As you can see, the TCP/IP model is more streamlined and practical, which makes it the go-to model in real-world networking. Understanding these layers and their functions can significantly improve your network design, troubleshooting, and overall communication performance. So, keep exploring, keep learning, and you'll become a master of networking in no time. Now that we understand the OSI and TCP/IP models, how do we use them? Well, these frameworks are not just theoretical models, but are indeed practical tools in the world of networking. They serve as vital roadmaps for network engineers and IT professionals alike, guiding them in designing, troubleshooting, and improving network communication. Let's take network design for instance. When designing a network, these models help in understanding how different network components will interact with each other. The OSI model, with its 7 layers, provides a comprehensive view of the network's functioning, allowing network engineers to pinpoint where specific functions should occur. On the other hand, the TCP/IP model, with its more streamlined structure, is particularly useful in designing networks that heavily rely on the internet. But what happens when something goes wrong in a network? That's where troubleshooting comes in. Network issues can be notoriously difficult to diagnose and resolve, but thanks to these models, we have a systematic way to identify and address issues. The layered approach of the OSI and TCP/IP models allows us to isolate issues at specific layers, making troubleshooting a more manageable task. Take, for example, if a user is having trouble accessing a web page. Using the OSI model, we can start troubleshooting at the physical layer, checking the cables and network cards, then move up to the data link layer, checking for any errors in data transfer, and so on. Similarly, with the TCP/IP model, we can begin at the link layer, inspecting the physical and data link aspects, then proceed to the internet layer, examining IP routing, and continue upwards. This systematic approach helps in identifying the root cause of the issue and fixing it effectively. Moreover, these models play a crucial role in improving network communication. They serve as guidelines for developing new protocols and standards, ensuring that they are compatible with existing layers and can effectively communicate with them. This results in networks that are more efficient, reliable, and easier to manage. Understanding these models not only allows us to build better networks, but also troubleshoot them effectively. Let's recap what we've learned about network system architectures. The Open Systems Interconnection, or OSI model, uses 7 layers to conceptualize network interactions. These range from the physical layer that oversees raw data transmission to the application layer that interacts directly with software applications. Each layer serves a unique function and communicates with the layers directly above and below it. On the other hand, the Transmission Control Protocol, Internet Protocol, or TCP/IP model is a more streamlined practical model with 4 layers. These layers correspond closely to the OSI's layers but combine some of them for increased efficiency. For instance, the application layer in the TCP/IP model combines the functions of the OSI's application, presentation, and session layers. Remember, the key to mastering network communication lies in understanding these fundamental models. Thanks for joining us on this journey through the OSI and TCP/IP models.